Keep it clean, keep it cool, and keep it grounded. You know who our guest is. It's Jeff Welton from Nautel with a bunch of great advice for us. Chris Tarr is along too with even more great advice. We got a good show coming up for you coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. I just realized my TWiRT light isn't turned on. Shame on me. I need to make a checklist. By the way, thanks to Charles Sather for building that light. That's really cool. Charles does great artwork and good engineering. Okay, so Chris Tarr is with me today. Chris, welcome into the show. Good to see you.
Good to see you too, Kirk. I just got back from the nice cold weather up. Believe it or not, there's an up north from where I live. I was up working on I tried a transmitter site where I had an antenna connection burn up. So I've been dealing with that, but back in the office today and glad to be here in the warm, not dealing with things that have started on fire.
All right, I go just a sanity check here. What's cold to you? Right now it's 25 in Nashville. I just got my gas bill from Piedmont Gas Company. It was $229 for last month. I do have kind of a big house. At least the electric bill is low. Chris, what's cold to you up there?
Well, I will tell you, yesterday I was out in the field and it was 6 degrees with a wind chill of oh hell no. And my heating bill this month is going to be probably $350, something like that. I would love to get 25. I mean, if we can get to 25, I will be a happy guy because I'll wear shorts. I'm good.
Shorts and flip-flops.
But, I mean, it was like being in Siberia. I was on the Minnesota side of the river and, the wind's blowing and there's snow all over and it's just freezing. And I'm just like, yeah, I'm done. I'm done.
Oh, wow. Well, our guest is someone who is familiar with cold himself. And without further ado, let's bring him in. Jeff Welton is here. Jeff, welcome in. Good to see you.
Hey, how you doing, guys? Now, the funny thing is that at this point in the game, based on what we're talking about, I'm the one in the warm area. It's 40 degrees here in Eastern Canada.
Well, it was 54, 57, something like that here in Nashville yesterday around lunchtime. I took a walk at the local lake. It was I was over bundled. I saw a guy in running shorts, of course, at 54 degrees or so. But yeah, it rained and things got cold last night, and it was down to 17 degrees overnight, and now it's 25. So but what's cold to you, Jeff?
So to me, for us, and I'm bilingual, I speak English and American, so I'll translate to Fahrenheit on the fly. But we don't go below zero here, hardly ever. So for me, once you get down into the tens, single digits, that's well below my comfort zone. And usually that's about the time somebody like Chris will drag me out to visit him when it's minus 30 degree wind chill or something.
I was going to say, Jeff likes to point out that even though he's in Canada, he's further south than I am.
Yeah.
Oh, okay.
So I like to get Jeff out here in the middle of winter so that he can experience the kind of fun that I'm dealing with.
The bliss. The bliss.
Jeff, we've wanted to have you back on for a while now, and I see you doing so many other things, webinars. Hey, you were on Barry's lunchtime recently, weren't you? What'd you talk about there?
Yeah, we do Barry's lunch. I usually show up usually the first Thursday of every month. This latest one, usually we try to talk about, maintenance and how not to make stuff go boom. On the rare occasion, we'll hit ferrites because, of course, that's my favorite topic ever. But usually what'll happen is Barry will call me a couple of days before and say, what do we want to talk about? And I'll be like, I don't know. And then we'll open the mics and he'll just pick something and we'll roll with it. And yeah, we have a lot of fun with those. I do some SBE webinars. Just did one this afternoon on all the fun with getting parts and materials. And I know in your day job you deal with that as well too. And then yeah, just a little bit of everything. Our own weekly in-house sessions. It's been fun.
What sometimes, we can't deliver something for a couple of months or 3 months or so. And one of the things I have to tell people is, look, it may take 852 parts to build this box that you bought from us. If we have 850 of those parts, we can't ship it to you. We have to have every single one of those parts, and they all have to show up at the factory at the same time so they can get all plugged together.
And that's say that's one of the unique challenges, and that's what we're running into a lot these days. I mean, I'll write a quote knowing that I've got about a 12-week lead on some parts, so that's what we'll quote for delivery. And between writing the quote and it getting signed less than a week later, there'll be a part where somebody comes back and says, yeah, no, 36 weeks on that one. And so we try to keep inventory up. And of course, you folks had the same challenges, but then there's some accountant looking, going, wow, you're paying asset tax on all this stuff. So yeah, it's an ongoing juggling act for sure. It's a lot of, I'm glad I don't have to deal with that part of it.
A lot of folks don't realize about this asset tax thing. And I remember first learning about that in fixing Continental transmitters 35 years ago. I asked one time, why does this rheostat cost $450? Because I think it's $68 from DigiKey or somebody, somebody else, Graybar or somebody. And they said, well, because we have it, it's exactly the right one, and we have paid tax on this thing year after year after year until you want to buy it. That's why. Yeah. And it occurred to me, and we're not going to get off on the whole tax issue, but man, it would occur to me that life would be a lot better if the government hadn't figured out to tax assets that are sitting around waiting to be sold, because they get more and more and more expensive every year when you do that, and it discourages manufacturers from stocking what you may need.
And then long-term support suffers and everything. And the thing that I've always argued is when you bought it, you paid tax on it. At that point, how many times do you need to pay tax on it? But that's a totally different argument that we could go on about over several coffee and a lot of time.
Yeah. So I came up with some questions, and Chris, you got a copy of them too. But Chris, I sure would like you to jump in with your own. Some questions we can ask to Jeff. The topic of today's show was scheduled to be something along the lines of, hey, almost every transmitter these days is solid state. And almost all of my transmitters are now. In fact, maybe now I think I still have 2 tube transmitters amongst the 15 or so transmitters in my group. Chris takes care of a bunch of transmitters, 40 plus or so. Every transmitter now, basically, though, is solid state. And one of the questions we have is, how are the different transmitters different? And yeah, I'm talking about either, brand to brand or technology to technology or era to era. How is a 30-year-old Nautel FM transmitter different from one that you would deliver today? So, Jeff, I wonder if you just might start out a little monologue and kind of fill us in on this, how our solid state transmitters different from each other.
All right, you're going to have to virtually throw something at me if I get a little too carried away. This is a topic we could talk about for quite a while, but obviously there have been improvements in efficiency. The solid state gear we were building in 1990, let's see, I did my first FM transmit. So my very first presentation ever, period, for Nautel was at the Alaska broadcaster, in October 1991. I was petrified, but that's a whole different conversation. And talking about solid state FM, which was a fairly new thing at the time. It was new for us. I think Gates Air had the, forget their first series, I'm sorry to say, but there were some others around, just not a lot at that time. The efficiencies weren't as good as what you could hit with a tube transmitter. They were typically tuned, so fairly narrow band, which was good for turnaround loss. So that was a plus, but it required a lot of tuning, a lot of tweaking. You sure weren't what you'd call frequency agile. They used a lot of fairly clunky parts, and current technology, HD, SNMP, that sort of thing. Yeah, no, forget about it. So a lot of that's changed. I mean, we've been building solid state FM for 30 years now, and I like to think, learned a few things along the way. So that's made a difference. Efficiency wise, we're up to, and this is a collective, we transmitter manufacturers, we're all around the same, but into the 70% range for overall AC to RF efficiency. I mean, it'll vary 70 to 75 depending on frequency, model, manufacturer, and whether or not they fudged the volts and current when they took the readings. But so yeah, it's the efficiencies are way up. Redundancy is about the same, maybe a little higher, as we've all got multiple power amps, and switching supplies have made a big difference in that regard. And it's a double-edged sword, and it's the argument I make with our engineering folks. They'll tell you that the reliability is a lot higher with switching supplies, and I'll say yes, but you're not off air if a supply fails. But if you see a red light, that's just as problematic. And if you see more red lights with this one than with the old one, to the guy on the end, that means more failures, not fewer. So, some of it is interpretation. But yeah, the stuff that would take you off air is a lot less common now than it used to be.
You mentioned power supplies, and it just occurred to me, yeah, power supplies are part of that AC in to RF out efficiency factor. So I hadn't really considered that. And you're saying today's switch mode supplies are a lot more efficient than old linear supplies?
So a transformer, and of course, anybody who's ever dealt with a big iron supply, transformer, rectifier, and capacitor filter knows that those things can get pretty toasty. Well, every watt of heat is a watt that's not going up the pipe. So absolutely, a switch mode supply can be anywhere between 95 and 98% efficient, compared to, on average, you're going to lose 10 to 20% of your efficiency on an iron supply transmitter in the power supply.
Chris, I'm sorry I butted in. Go ahead with your question.
Oh no, one of the comments that come up, with solid state transmitters, which is kind of makes me laugh, is go, well, unlike the tube stuff, the solid state stuff is disposable. You run it for 10 years and you get rid of it. And we were talking a while back about a used solid state transmitter I bought from Reno, Nevada, one of the early models. I think it's an FM5, and it arrived looking like brand new, and it is now my main transmitter. And it, since I turned it on earlier this year, I haven't had a single call from the site. So, I think that there's a bit of a curve, I think, especially with older engineers. Although I guess I say that and I'm getting old, but you can't do better than a tube. And I've got several tube transmitters. We're slowly migrating them to solid state, and something I'm sure we'll talk about here in a bit is the availability of tubes. But I find that, and you've mentioned this many times in your webinars and things, that with the solid state transmitter, you keep it clean, you keep it cool, and it's happy. It'll go and go. And you make sure you put the toroids in and everything else to keep it, because they are susceptible a little bit more to changes in electrical loads. But that's something that's pretty easy to overcome if you do it right. Surge suppression of the building, liberal use of toroids and things like that. But it amazes me that, a transmitter that was sold in the 90s, I put in, and I'm expecting to get, probably another 20 years out of it. And it operates like brand new. And it's because the guy who had it before me, treated it well. The only reason he got rid of it was he needed a higher power transmitter. So, they do last as long or longer than tube transmitters. And because you're not dealing with the high voltage in a solid state rig, certainly most of the failures are not nearly as spectacular, which I guess could also be a side.
Right. And I mean, one of the other things, there are still consumable items, fans, that would be a prime example. But I mean, a fan for your typical solid state rig, depending, the ones in our current boxes are about 30, $40 a piece. The ones in, like the one Chris is talking about, those feather fans run from us $200 a pop. From DigiKey or Mauser, any of those, you can still get them for $100 or so. And again, that comes back to the asset tax we were talking about. But point is that you can stock those parts, and it costs a whole lot less to replace a fan every year or so than to do a tube every year or two. And yeah, that's a good segue. As a rule, you're not finding not just the availability, but you're not getting the life cycle. I mean, I think it's going to be very rare going forward to get 7 to 9 years out of a tube, no matter how good your filament voltage maintenance is.
Yeah. Hey, it's This Week in Radio Tech, our 579th episode. I'm Kirk Harnack, along with Chris Tarr, and Jeff Welton is our guest from Nautel. When we come back from this quick break, I want to ask Jeff, he mentioned that efficiencies have been going up, and I'm curious about whether it's due, we talked about the power supplies already, but whether there's more efficiencies in the actual amplifier parts, the MOSFETs or whatever they are called these days, or our understanding of how to build more better circuits around the MOSFET. So, which has gotten better, or both. So I want to hear a little bit more about that. And we're also going to ask Jeff kind of a silly question. Why isn't there a solid state replacement for a tube? Why can't you buy a solid state, 4CX 20000 A7? So that'll be interesting, because you used to be able to buy solid state replacements for some tubes, like mercury vapor rectifiers and so forth. Our show This Week in Radio Tech is brought to you in part by our friends at Broadcast Bionics and the incredibly cool Camera One system. We'll be right back.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
Thanks so much to Broadcast Bionics, makers of other software to make your content better, make it more accessible, and make your social media really on point with the best ofs, any show, contesting, winners reactions, good stuff like that. Check them out at bionic.radio, bionic.radio. Thanks again to Broadcast Bionics for sponsoring This Week in Radio Tech. All right, Kirk Harnack, Chris Tarr, along with our guest, Jeff Welton. Everybody loves having Jeff Welton on. We find out so much good stuff. So, Jeff, about my question, in terms of the amplifiers and the components that are used and the circuitry surrounding them, what, if anything, has gotten more efficient over time?
So the amplifiers definitely, as we've gone from VMOS through the various iterations of that up to LDMOS today, the transistors have gotten much more efficient. Now, I'm going to quantify that a little bit because then we made them all linear for HD radio and went backwards 2 or 3 steps. So that's a whole different, because, of course, MOSFETs are like a digital switch. They're designed to be on or off, not in between. And when we want to run them linear for HD, that's exactly what we're forcing to do. So that's kind of cool. But even with that said, between the power supplies, combiner technology, a little bit of better broadbanding, we've kind of gotten to the point now where an HD transmitter is about as efficient as a predecessor analog transmitter would have been. So I've had situations where people have upgraded a transmitter, increased the HD carriers, which of course should increase power consumption, and seen the power bill go down as a result. So,
and this is interesting. Let's and if Chris Tarr wants to jump in here for helpful part of an explanation, a lot of engineers. Now, I have not personally installed any HD systems. I've consulted on audio processing for HD systems quite a bit, but one would, without knowing what's going on, and a person not experienced might think HD. Well, that's digital too. Why do we need an amplifier that is not a Class C amplifier? Why do we need an amplifier that does a range of amplification, not just on or off, on or off, on or off? And so help us understand why when you add HD, you actually have to have a final amplifier that is more linear and less nonlinear than we've been used to in FM broadcasting. Either or both of you want to take that question on?
Chris, you want to hit?
No, go ahead. You know a lot more about this than I do.
I tried to pass that buck and it just bounced right back and hit me in the face.
It's called flinging the dead cat onto your neighbor's porch.
That must be a Wisconsin game. I'll have to ask my wife about that in a bit. But, so the short answer is because we're not just doing FM anymore. Whether we're talking AM radio or FM radio is irrelevant in this regard, because these days we're doing AM and FM on the same transmitter both. In FM radio, of course, the analog carrier is frequency modulated. The digital carriers are amplitude modulated. Because of that, the power curve spreads out across the band quite a bit. And so we need a very linear antenna system. We need a very linear path through the antenna system in order to minimize the intermodulation between the digital carriers, the amplitude modulated digital carriers. So that's the big reason. Because of the interaction with AM and FM, the system does have to be a whole lot more linear. And I'm sure that if any of the folks in our engineering department are listening to this, they're rolling their eyes and going, man, you couldn't have explained that any worse than he just did.
But it's true. And that one of the things that early on that people were having issues with in launching digital radio is non-linearity of the rest of the transmission system. So, they were trying to stuff all these carriers into an antenna that was very narrow or not exactly tuned correctly or, whatever. And it was causing intermod problems. You were interfering with yourself, essentially. And so it took a long time after this technology was released to get people to think of it as an entire system. Everything you have in the chain has to be able to pass that. And there's a lot of stuff going on there, not only power-wise, but as you said, with AM and FM and the fact that, there's the difference in power between all zeros and all ones, that you have to account for all of that. So that was always the struggle early on, not only with efficiency, because if that isn't perfectly linear going all the way out to the antenna, your efficiency suffers as well because it can't pass all the bits. So, those are some of the things that I think now we've gotten a lot better at. But early on, there's a lot of struggles. And I think sometimes, the IBOC got kind of a bad rep because, it doesn't work, or, I put it in and all of a sudden, my coverage is different, or I'm hearing noise or whatever. And it's because, they're trying to stick this onto, 20-year-old antennas that, or transmission line that's been there for, since the station signed on in 1960 or something like that. And that's going to cause some problems. So, Not only has the transmitter manufacturers had to work on that, but it requires a little effort with all manufacturers to make sure that it can easily pass all of this information.
Right. And I mean, I've run into similar situations. You remember, like, way back, not that many years ago, a lot of the antenna manufacturers, especially up in our part of the world, used to what they call tuning on the curve. So they'd
Right.
tune the antenna and then they'd off tune it so that as it iced up during a storm, it would go through the sweet spot, come out the other side, and stay on the air longer. So the problem is with HD, of course, at that point, you're automatically running into a bad load because it's nonlinear, it's non-symmetrical on the upper and lower sidebands. And so you, as Chris said, you're interfering with yourself because you create digital intermod. What was the word? Spectral regrowth. That was it.
Yes.
That was the phrase.
Yes. Yeah. And I actually was dealing with that exact issue. One of my stations when I was with Intercom, where we were getting after I turned on HD, we were getting complaints of people saying that, oh, somebody's interfering with you. All of a sudden, I'm getting static now in places where I wouldn't get static. And, I at first kind of scratched my head and went, this doesn't make sense. Well, then I swept the antenna. And of course, they tuned it up so that it would fall into place when it iced over. So really, it was linear at about, maybe a megahertz up, 0.1 or whatever. Actually, yeah, not 100 kilohertz up. So that when it would ice up, it would slide in. Well, what was happening was the lower sidebands were just getting, thrown all over the place because it couldn't pass through the antenna. So we were interfering with ourselves. And yeah, so that's a big thing up in this area that, people don't think about is, analog obviously is a lot more forgiving, but when you've got all of these high powered, subcarrier, carriers down below, and there are multiple carriers, it's similar to OFDM. You have all those below your main carrier. If those are getting squished and rejected and not passing through, where's it going to go? It's going to regrow into the analog area, and you're going to hear it. So, efficiency nowadays is more than just the transmit.
This is a bit analogous to back in the older days of analog only FM. At one point, I was called to a transmitter site, a mountaintop transmitter site in eastern Kentucky or western Virginia, depending on if you were inside or outside the building. Actually, the state line went right through the front of the building, and the station owner was complaining about the station was sounding very staticky, very bad, especially down in the hollers, down in the valleys. And of course, they thought it was some kind of audio problem. Well, I got to look at the transmitter, and it was a BE tube type transmitter with a half wave a cavity, not a quarter wave cavity like so many other transmitters at the time had. And it didn't take too long to figure out that it was just really poorly tuned. And I used that technique where you use an oscilloscope and you take a feed of the composite and you take a feed off of the off the RF tap, and you XY them and make a Lissajous pattern on your scope, and you try to get the most linearity, try to get a straight line there. You're not going to get a straight line, but at least you try to not have it, a cuspy curve sitting off to the side somewhere. And so I tuned up the transmitter. It had a little bit less efficiency, but it was far more symmetrical in its behavior on the sidebands. And I called the owner. I said, well, how's it sound now? And he's down there in his Cadillac somewhere in a holler. And he says, it sounds great. What'd you do? I said, I tuned the transmitter. So that was transmitter induced synchronous AM noise. That's what it was.
Noise, yeah.
AM noise. And so we got away. But that taught me something about bandwidth and proper tuning. Well, HD radio is much more susceptible to this. And you got to have even wider bandwidth and better linearity out there at the edges of your occupied bandwidth space. TV has a lot of the same problems too, where they've got to they get that spectral regrowth going on if they don't take care of it.
Exactly. I mean, it's all physics when you get right down to it. And, the funny thing is, and I make this comparison in AM all the time, is it Carl, I'm going to get it wrong, but I think it was Carl, he's either Carl Smith or Carl Jones, wrote the paper in the 50s about optimizing directional AM antenna arrays. one of you can jump in and correct me when I if you know the answer, but one of the two, I've got a copy of the PDF, and that technology, that theory hasn't changed. The funny thing is that the things that interact with analog and cause things like intermod or AM noise with the reception issues are also an impact with HD. So you optimize your system for HD, you're optimizing it for analog as well.
That's like AM stereo. When AM stereo first came out, people were having to increase the bandwidth or tune the bandwidth of their arrays in order to pass AM stereo. Or, and this goes for a lot of things. There was a story out about how the composite clipping with the modulation sciences composite clippers back in the day, if you clipped heavy enough, the splatter would just generate noise like buzzsaws in the analog audio. Because again, anytime you're trying to squeeze a whole bunch of stuff together and squish it and try to get it out a smaller pipe, you're going to cause those issues.
So coming up in our conversation with Jeff after our next break, we're going to talk about troubleshooting techniques for solid-state transmitters. I think a lot of us, I've put in a number of FM solid-state transmitters lately, and frankly, I don't know much about troubleshooting them. I can go read the manual, and some of them have been Nautel transmitters, some have been another brand, and I don't know the first thing about troubleshooting them really, except for looking at the indications of the front panel and calling support, say, what do you think? And Jeff, I got to tell you, in some faraway places, in Mount Kahili in Hawaii, and on Mount Olateli and Mount Alava in American Samoa, where I have transmitters, Nautel has been invaluable at asking, okay, what does this say? What does this say? What does this say? And that means this pallet is bad, and we'll send you a new one. And so that's been really helpful. But I got to believe there's probably some more that I and others should know about troubleshooting solid-state transmitters. Before we get to that topic, and I'm going to get to that after the next break, Jeff, I want to ask a little bit about airflow considerations and environmental considerations for solid-state transmitters versus tube transmitters. Let's say I'm going to put in a 10 kilowatt FM Nautel solid-state transmitter. I'm replacing a 10 kilowatt FM tube transmitter. That FM tube transmitter was almost assuredly blowing lots of hot air outside. And to replace that air inside, I may have been sucking air in through some filters from the outside. Maybe the person who installed it didn't even think about this, and air just comes in randomly through cracks in the building. Talk to me about what are a couple of the most important considerations for airflow and environment for an FM transmitter of a 10 kilowatt power level.
So this comes back to exactly what Chris was talking about earlier. If you keep them clean and keep them cool, they're going to last longer no matter what the structure is, whether it's solid state or tube, regardless. I'll give you a prime example. I had one of our guys was telling me today, he got a call from a guy and he's putting together a project. And the guy was asking about what we could do for additional filtering in the transmitter. He goes, because the site's filthy. And he goes, it blew up the last transmitter and it blew up the one before that. And there's just a mess. And it's like, well, why don't you invest a couple of $1,000s in putting in a clean air room or doing some positive pressurization? And he's like, a lot of reasons why they couldn't change the building itself, but they're perfectly willing to spend 10 grand on additional filtering in the transmitter. And it's like, at some point you kind of look at it and you go, you need to invest a little bit in the facility. Now, that said, what I tell people is I like to see positive pressure. And again, solid state tube is irrelevant to me. If my transmitter's got a throughput spec, and we specify it in the pre-installation document for everything we build, like it may say 900 CFM, cubic feet per minute. Well, if I put a 1500 CFM intake fan on the building, and run it through a pleated paper filter or whatever, some kind of decent quality air filter, and then put a 1000 CFM exhaust fan, at that point, I'm bringing more air through that filter into the building than is leaving. So what's going to happen is air is going to leak out every crack and crevice instead of sucking dust in through every crack and crevice. And I guarantee you, just doing that on its own, now you got to do the obvious stuff like directing the cooling air through the equipment instead of around it. But if you cover that right off the bat, you're going to see a huge difference, especially in cotton season.
One
Well,
more. I'm sorry. Go ahead, Chris.
I was gonna say, a great example of this is, we just bought one of Jeff's Nautel transmitters, um, 30 kilowatt HD, and one of the things you have to take in consideration is if you're going from analog to HD, there's going to be a lot more heat because it's less efficient, therefore more heat. But the way to think about it is, as my coworker Dave, who owns the company, we don't have the transmitter turned on yet because we're going to get the HVAC redone. He's like, why are we spending all this money on a brand new transmitter when the cooling in the building is so horrible that it just coats everything in dirt? We're not going to get our shiny new transmitter dirty like that. So we're doing exactly what Jeff is talking about. We're going to do the room with positive pressure. We're going to do some things that are going to control the humidity and that sort of thing to give this this transmitter a long life. And Jeff, said it, so succinctly. It doesn't make sense to buy a new transmitter like that if you're not going to invest in making sure that the environment is clean. Because, solid state or not, how many times have you opened up a tube transmitter and the tube cavity is just coated with that fine dirt or whatever. That's how arcs start. That stuff gets, humid and it becomes very conductive. So, that goes for pretty much anything.
And that ties into the analogy I use, and I'd say I just did a webinar for the SBE on supply chain challenges earlier today, and at the tail end I was talking about educating management, and I used the analogy of a car. And Kirk, you were talking about the owner with his Cadillac down in the holler, and I'm willing to bet he gets regular oil changes on that Cadillac. So it's easy to sell the maintenance if you use an analogy that they can understand. And keeping your transmitter clean is somewhat similar to doing the oil change on your Cadillac. It's going to make it live a whole lot longer.
Hey, it can also help to know what the hourly shop charge is at the BMW dealer, so that you can more easily justify your hourly rate as a contract engineer. Because that's it's a bit more specialized being a contract engineer, I think.
There you go. You can cheerfully tell them that for one of our guys to walk out the door, plus expenses, it's $1,800 a day.
Yeah. It's about that for my employer, too. Hey, it's This Week in Radio Tech, our 579th episode with Jeff Welton. Chris Tarr is my co-host. And our show is brought to you in part by Broadcasters General Store. You can get anything you want at Broadcasters General Store, to steal a phrase. And they carry the whole line of broadcast tools equipment. Now, one of those items in broadcast tools, we've been talking about it for literally 2 years here because it's such a useful box, and that's the Broadcast Tools ProMix 4. Now, the ProMix 4 is, it's a little bit different. I mean, on the one hand, you might say, why would I buy an analog audio console these days? Why would I buy a mono audio console these days? Well, because this audio console is for some particular uses. It's great. It's great for sports broadcasting. It's terrific for remotes. It's also good for a small studio where maybe you want to just have it available to do voiceovers, voice tracking, where jocks can record their voice tracks for the day, their liners and so forth. It's the Broadcast Tools ProMix 4. It's a compact, yet in many ways full-featured mono audio mixing console. Now, it features 3 combination mic line inputs. So, hey, you can send any jock out. And excuse me if I'm using the colloquial word jock, disc jockey, on-air personality, you know what I mean. You can send somebody out who's not necessarily an engineer, and they can plug their microphone right into the back of this thing because there are just 3 female XLR connectors, but they also have that 1/4-inch connector in the middle. So if you've got something that comes in on a 1/4-inch tip ring sleeve connector, you can plug that right in as well. It also has a 4th input that can be switched between being a balanced line input or the built-in USB audio interface. This is a common USB interface. You just plug it right into your PC or your Mac. No driver needed. It just looks like a sound card now to the PC or the Mac. And then you can bring PC audio into the ProMix 4. And of course, ProMix 4 audio, program audio from it, back to the computer, which means you can run it into, Clean Feed or whatever program you may be using on your computer to send audio back to the radio station. It also has 3 of the quarter-inch sized stereo headphone outputs. They're included with individual controls for volume, mix, and pan, allowing custom headphone mixes. Other features, well, it's got a switch selectable program limiter. And so that way, Chris Tarr will identify with this. Your sports guy can say loud things like, he shoots, he scores! And it won't distort the output because it's got that built-in switch selectable program limiter. It has a monitor output with muting, so it's okay for a studio. You turn your mic on, mutes the monitor output. That's good. And it also has a volume control for that, obviously. It has a mix minus output, so you can hook a telephone hybrid into this. You can hook up, let's say, that Bluetooth audio gadget from Angry Audio and hook up your cell phone to that. So it's got those things. It also has an on-air light relay output, so you can hook up an on-air light to that. It's a great choice for remote broadcast, also for podcasting. Just a slick little console. Check this thing out at Broadcasters General Store. Their website is bgs.cc. I'll tell you what, you need to give them a call at Broadcasters General Store. Their phone number, you can memorize this or jot it down, 352-622-7700. I'm telling you, for years, I have dealt with them on the phone. They give you quick, accurate information. They're pleasant to talk to. They're eager to talk to you and give you the best possible price. And they're usually really good at giving you a delivery date, whether you need it overnight on some things. And I have ordered things and gotten them overnight, even delivered to a little small town like Indianola, Mississippi. Or if it's going to be a delay or a few days delivery, they can usually give you a pretty accurate delivery date. So that's really helpful. Broadcasters General Store, bgs.cc. I love these folks. Really good folks. Family operated business. And you're going to like them too. All right. Thanks a lot, Broadcast General Store, for sponsoring This Week in Radio Tech. Chris Tarr is along here, along with Jeff Welton. Jeff, I want to know about troubleshooting techniques for solid state transmitters. As I mentioned, I've got several of them on the air now. And, if one, I got some older Nautels that have popped a module, stayed on the air, reduced power level. What are some troubleshooting techniques if I get there and it's either reduced power or completely off the air? What do I need to start looking for?
So, that's the funny thing, because you and I very first met, you were looking at a 50 kilowatt AM in Nashville with a blown power supply. For what that's worth.
Yeah.
It's about 25 years ago, I think. Time flies when you're having fun.
It does.
Anyway, so the big thing, almost every solid state rig out there will have some sort of alarm interface, whether it's LEDs on the front, whether it's full graphic, textual flow chart, singing and dancing, everything. The first thing you want to do is figure out what lights are red, whether it's through the flow chart or the interface. My running comment is that every transmitter out there today, solid state, tube, AM, FM, TV, CB, I don't care, has only got 5 blocks. It's got an exciter, it's got an amplifier, it's got a filter, it's got a power supply, and it's got a control circuit. So your problem is going to be in one of those blocks. And if you can break it into bite-sized pieces, it gets a whole lot easier. Now, with us, for every light in the transmitter or every alarm, and that's the thing, when you go up to one of our boxes now, you'll either log in through the user interface or you'll look at the touchscreen on the front panel if it's one of the bigger boxes. And there'll be an alarm indicator of some sort, whether the status light is red or orange or whether there's a little button that says alarm. And if you haul up the active alarms, it will usually give you a text description of what that alarm is. Usually that description is intuitive enough that it'll steer you in the right direction. It'll say power amplifier or power module 1, PA2 fail. Well, that takes you right down to the specific amplifier palette. So you've narrowed it down pretty fast. But even if it doesn't, if the alarm says something like host mode mismatch and you don't know what that means, if you go into the troubleshooting manual, and we do break our manuals up by function, so there's install, pre-install, operations, and troubleshooting. And if you go into the troubleshooting manual, there is a table listing every single alarm in the transmitter and where you should start looking, and includes detailed, like, go to this page for ideas on how to troubleshoot this. So, I joke with people, it's like, you should read the manual, it's all in there. And I know when we're under pressure, you don't have time to go sorting through a 500-page manual to figure out where to find something. But by all means, give me a holler and I'll tell you exactly where to look in the manual, because odds are I've probably already been there at least once. And the same with the other support guys. So, go to your interface, whatever your transmitter has for an alarm interface. Again, could be LEDs, could be a full display, could be like the old Z series had the flow chart on them, and get yourself down to the right block and then break it from there.
And I will say,
go ahead, Chris.
I will say, Jeff is right with manuals for all the transmitters. I do have some experience with Nautel where, for example, PA drawer fails, or an IPA drawer fails rather. And, Nautel has a really easy chart on how to rewire a PA module to make it an IPA module. And I've done that procedure a couple of times. But it's just like learning a tube transmitter. Learn how each block works, and you start to, kind of intuitively know what's going on when you see the error messages. And then there are, simple tips like swapping modules around. If it says the PA module has failed, well, swap it with another one. Does the failure follow the module, or does it stay in the same slot? Same thing with power supplies. And so, first of all, there's those sorts of things that are easier to troubleshoot. But then there are also things like, an exciter alarm. Well, sometimes you get an exciter alarm because it senses there's nothing going into it. So, maybe something as simple as, my digital input is not sending a clock. And so it seems like it's just, there's nothing there. So, it follows the same lines as troubleshooting a tube rig. It's just that it's a completely different structure. The basics are the same, but the structure is different. The mode mismatch, well, something's set to HD rather than analog, or, whatever. You start to learn it, and the troubleshooting gets easier. And then, of course, like Jeff said, all the manufacturers I've dealt with support with, Gates Air and Elenos and some other places, and they're all uniformly good. And, they'll usually get you on your way. I will say it's actually, I think, in a lot of ways, easier to troubleshoot a solid state transmitter than it is a tube rig, because a lot of those resources are available, and it's so modular. It's pretty easy to swap things around to see which part is bad.
Typically, there's less to bite you too.
Yeah,
right. Exactly.
That doesn't mean they're safe to stick your fingers in, though.
Right, and that's an important distinction, because depending on where you are and whether, and our general rule of thumb, we work with IEC 215 and some various safety policies. But if you need to pick up a tool to access any component, like you had to unscrew a panel to get to it, odds are there's something back there that can hurt. So just be careful where you put your fingers. The other cool thing these days, and I had this discussion on Facebook a little while ago, when we started doing it, I kind of poo-pooed it, because I'm kind of a Luddite. I like big old paper manuals that I can write notes in and flip through. But I've gotten really used to having all my manuals available on this thing right here. And the ability to I can open a PDF for any current transmitter we have right now. And now I've got something that I can search with character recognition. So I could, if I saw mode mismatch, for example, in my NV10LT, which I shouldn't, because I don't have operating modes in that typically. But if
Not an LT.
But if I did, then I could open up the troubleshooting manual for the NV10LT, type the word mismatch into Adobe Acrobat, and it will immediately take me to the description of the alarm. So, that's I think almost every manufacturer these days makes their manuals available on their websites, whether it's through a login portal like we do, or whether it's directly available. That depends on the manufacturer. But by all means, if you maintain a bunch of stuff, it's worth your while to load all the manuals for everything you maintain onto like a OneDrive account or something you can get from any device.
I think this was a tip that Chris Tarr left us with years ago on maybe an early version of This Week in Radio Tech, putting manuals. And back, now we have internet access in most places we go to. But Chris was advocating, putting these PDFs on your iPad. That was a great use for iPads. It's big enough to actually see something. And Jeff, you mentioned nowadays with character recognition in PDFs that you can easily search for things. That's true, but every time I search for a character in a Nautel PDF, it always references you.
Sorry about that. Yeah, at some point I told them they're going to have to stop putting my picture in those manuals. But
you know what? Actually, one of the things I've done is I've even expanded the manual thing. I've gotten a couple of friends together, and I share the folder, and we gather manuals for everything. So even if it's something that I don't have, it's something that somebody else has, and I'll run into something, one of those devices in the field, and I'll have the manual sitting there. I have it divided up by manufacturer, and I don't leave home without some sort of device where I can take a look at these manuals. They're fantastic that way.
And I mean, for me, I use sorry, Kirk, didn't mean to interrupt.
Okay.
I use a OneDrive account because then I can locally synchronize it onto my both my laptops. And that way, if I've at a transmitter site and I don't have internet, I've still got local access to all the manuals.
So coming up, we're going to ask a couple other questions of Jeff about what are some of the most common, and I'm not going to say the common failure modes, but some of those common preventable failures. So, Jeff, I'm sure you've seen failures out there in the field, and you know which ones could have been prevented by maybe, keeping things cool, keeping things clean. Maybe there are other things as well. And this will probably be your chance to extol the virtues of ferrites. This Week in Radio Tech is brought to you in part by my friends at Angry Audio, and this is one of the newest things out of the Angry Audio product line. It's under the Studio Hub brand name. This is a world panel. I'm holding that up there well enough you can see it there. This is a world panel. And, what a world. I rarely worked in radio stations that had a world panel. But if you've got like a TV station come in, or you've got maybe you have a disc jockey who brings in one of these big cases that has 2 turntables in it, or 2 mock turntables, and they need to get audio out of it and into the audio console. Whatever, temporary connection to your station's audio console, your station's monitoring, maybe your station's headphone amps in your studio, a world panel can really do you a good job of that. Now, most world panels that I know of are just totally passive, but not this one from Studio Hub. It has active componentry in here. It does require power. 16 volts AC goes in the back right here. There's a nice big ground lug on the back here. And this gives you buffered inputs and outputs to your audio console and your monitoring, things that normally would come in and out of the audio console, and in all different formats. So you've got on here unbalanced line in. So you have a little jack going from a cassette player into here. You got unbalanced line in. You've got got that on RCA connectors as well, and on XLRs and 1/4-inch tip ring sleeves. Right there, you've got every common format that's used for analog audio. You've also got outputs, same way, on a 3.5 millimeter tip ring sleeve, or on RCAs or XLRs and out. Plus, it has room and places for AES-EBU digital in and out. And it's also got a couple of, these are passive, these are just pass-throughs for a network connection. Maybe it's a Studio Hub style connection. Maybe it's an Ethernet connection, whatever you want to do. And a USB connector as well, right there. So maybe that goes into a PC, or it allows you to take a PC and go into something else. So this is really handy. A beautiful piece of gear, well designed. You're going to get great audio into and out of it. And your gear is going to be protected from the who knows what TV station or radio equipment that somebody else is bringing in and plugging into it. And that's important. Check that out from Angry Audio. The website is angryaudio.com. Love these guys. They're right down the road from me in Franklin, Tennessee. And that's where they do a lot of their manufacturing. They actually do manufacturing right there. My son and I got to visit with Catfish and AJ and everybody else there at Angry Audio. Good place. Check them out, please. And you can get that from your favorite dealer, but go to the website and find out what you want, and then go ask your dealer for it. All right, our show is brought to you also in part by my friends at Max Connect Wireless. Here's John Takak to tell you more.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It has also given us the ability to expand as needed in a secure fashion.
Good stuff. This one happens to be the PepWave 4G LTE modem, but others work as well. The key, the secret, is the SIM card. It's on the Max Connect wireless network, and you get prioritized 4G LTE data. Your data goes through before all those schmucks in the stadium doing a Facebook update during halftime. And the only people more important than you are first responders. So your data goes through. Check it out. It's really cool. Max Connect. That's spelled funny. So take note or look at our show notes, maxconnect.com. Really useful for remote broadcasts and for transmitter site remote access. All right. We've got a few more minutes, and we've actually added one more commercial break here before the end. So it's not time for the tip of the week just yet. We got more to talk about. And let's see, what was I going to yap about here? Somebody remind me. Chris. Yeah, go ahead, sir.
Yeah, just real quick before you go on to your line here, Jeff. I recall you talking about at what it might have been WBA or something, and I thought this was really interesting with your tech support. How you guys have a line of questioning right off the bat to kind of figure out what kind of person you're talking to technically to make sure they're not going to hurt themselves. Is that something you guys still do?
To an extent, I think we all do. I think anybody doing frontline support does a little bit of triage because, yeah, I mean, we run the range. I'll get calls, tech support calls from folks who are as experienced as you or Mark Persons, just incredibly intelligent people, all the way down to somebody who, I've walked disc jockeys through amplifier replacement before. And, they may not have any technical skills at all. So, my favorite is the guy who calls and says, look, I'm the owner. I don't know anything technical. Here's my problem and I need help. Right off the bat, I know we're going to walk you through very carefully. We're not going to touch the Bernie parts. But yeah, you do a lot of triage like that and a lot of 20 questions to try to find out the skill set of the person you're talking to.
Yeah, when they find out it's Chris Tarr or Mark Persons, they say, don't worry, turn off the breaker. Here's what you're going to do.
Yeah. Well, no, they actually do say that. It's like, oh yeah, I've heard about you. Go over and turn the brakes off first.
All right. So the question that I had was about preventable failures. So I'm sure, just as with any company has, the most common failure modes for a given piece of gear. Of course, I realize you make a huge range of transmitters, but what are some of the most preventable failures, Jeff?
So most of the most preventable ones, and this would probably go beyond our gear to just about any gear, are when something gets done radio station temporary and doesn't get permanently fixed. So as an example, I'll take a tube transmitter, went off the air because maybe something jammed up a louver and the back pressure kicked the airflow switch in the squirrel cage blower. So they know the blower's still working, so they bypass the airflow interlock to get them back on the air, which is great until they don't fix the actual cause of the problem. And then they do have a blower problem, and then they melt the tube final, the tube socket down into the power supply. So, and that can happen in solid state too. If you have to bypass an interlock for any reason, make sure you figure out what caused the failure originally and fix that at some point in the not too distant future. You can run with air filters removed. You can run with fans bypassed, but you do need to solve the problem. So I think the biggest preventable issue I encounter is radio station temporary. The vice grips holding something together to the point where it oxidizes and stops being a connection, that sort of thing.
Oh, shoot. I kind of like leaving vice grips doing things.
I told the story.
It's like free labor,
I told the story earlier about the station. They'd lost the feed to their AM. The copper coming out of the ATU had broken loose, and so they jammed it together with a pair of vice grips, and that's fine. Radio station temporary. They're back on the air. Everything's beautiful. I came by about 3 years later. Vice grips were still there, except now they were aviation orange because the tower crew had painted them.
So you always like to talk about ferrites, and I know that ferrites, must have something to do with preventing preventable failures. So tell me about ferrites.
So ferrites on their own are just a chunk of carbon iron filings and epoxy. Ferrites in conjunction with good grounding and properly installed surge protection, all of which are critical, can make a difference because they can help raise the effective impedance of your equipment to a surge so the energy goes around it through the surge protector and out the AC line. And there's the thing, surge protector is shunt type MOV surge protectors bidirectional. When lightning hits your tower and spikes ground potential at the base of the tower high, it can decouple it through to the millions of miles of cable and ground that the power company so graciously provides.
Yeah.
It's not, the bulk of the failures that we see, and this is undocumented and unproven. It's just my wild theory after 31 years of been there, done that. I think the bulk of the power switching supply failures we see are actually ground surges looking for a place to get out to the AC lines versus AC surges themselves. And that's where a surge protector can come in very useful. Having a ferrite on both the AC and the coax can help raise the effective impedance. So you're playing a voltage divider game and making the transmitter a slightly higher resistance than the opposite path. So again, it's just a little bit more controlling where it goes.
If engineers want to do a little bit of research on this in education, I recently saw a couple of videos on YouTube explaining about power transfer within copper wires, right? As we're all familiar with, from the power company to us. Okay, some of them may be steel, I guess, but whatever, aluminum. They come in the building. They're copper wires from the breaker box and the surge protector, the MOV surge protector, over to our transmitters. And I think one of the things that we don't realize that helps ferrites really be so effective is that this one video was trying to persuade you, and they almost did, that it's not so much power going through the copper wire. It's the power is actually from the magnetic field that gets set up around the wire. And it was just a different way of thinking about energy transfer. And, I was almost convinced that, that is an interesting way to think about power transfer. Now, I'm not explaining this very well, but by the time I watched the video, I thought, that is a really, and they did some experiments to show that if you break that magnetic field, all of a sudden you have a very high impedance wire here, and it doesn't transfer power very, very well. So a ferrite being a ferromagnetic, can break that cycle, can break that up, for high frequency things, can really knock that down. Now, when you mentioned it has to be well grounded, that doesn't mean the ferrite ring itself needs to be well grounded, right? Okay.
No. So let's look, for example, again with the antenna. So we've got an antenna, maybe we're an FM, so we got an antenna hanging up on a tower 1,000 feet in the air. Now we got 1,000 feet of coax coming down with a ground kit every so often, depending on who installed it. And depending on who installed it, they may or may not have scraped the paint off the tower, so it may or may not actually be physically electrically connected to the tower at all. So those ground kits, they're pretty, and I'm sure they do something, but I don't think that in a big lightning strike, they're going to decouple a lot. So now all this energy comes down this several 100-foot tower heading to ground. Maybe the base of the tower is grounded. And at that point, what do I have running? I've got this insulated conductor right beside it. So, and where I come from, we call that a capacitor. So at that point, a lot of energy, a lot of energy is going to get transformed or transposed onto that coax shield. Now, the coax shield being grounded is great at the base of the tower, but again, that ground needs to connect to our surge protector ground, and the surge protector connects to the AC, and that's our parallel path. And if we don't have those tied together, then at that point, and I'm talking with my hands because I get excited and I do that, but yeah, you need the ground on the coax shield. You need your equipment grounded with a decent single point ground so you can minimize the number of alternative paths, if you will. And then you need a properly installed surge protector between that ground point and the AC lines. And if you throw all those together, then you can make a big difference in the amount of what I call incidental failures, the stuff that could probably have been preventable with a minimum of investment.
I'm going to pivot right into a final message from our sponsor, Nautel. Nautel's back sponsoring because they want you to know about their Transmission Talk Tuesdays. You can go to nautel.com/webinars and at Transmission Talk Tuesdays. They're not ready yet as of this moment for signups. They will be hopefully in just a few days. You can go ahead and pre-register for several Transmission Talk Tuesdays in February. But I've got a quick message. This is a good clip from a recent Transmission Talk Tuesday with Jeff Welton. So let's roll that, and we'll be right back with our tip of the week.
One of the other things that we wanted to talk about was site hardening, and this is just something I grabbed out of a YouTube video. Somebody throwing a freezing rain shield over their heat pump at their house, but it's really not something that, especially in cold weather country, that you laugh at too hard, because having ice come off a tower and punch through the roof of a building can make a heck of a mess.
So we're going to have a tip like this from Nautel every week. And also I'll be reminding you to register for the Transmission Talk Tuesday. So you don't have to go to the website right now today. They're not ready for registering yet in February. Jeff, do you know how soon that's likely to open up, that registration?
So Fiona is waiting for me to fill out or to send her the descriptions and everything she needs to actually create the registration sheet. So that's on me. My goal is to have it done by tomorrow. So I would hope to see registrations open very early next week.
And here, Chris and I are keeping you from your appointed duties. I'm sorry about that.
Wouldn't be the first time.
No,
Chris,
at this point, all you're keeping me from is a board meeting.
Our time is drawing nigh when we've got to run. Chris Tarr, I wonder if you might have a final question or a tip of the week for us.
I have a tip of the week for you. Tip of the week. So this came up to in my mind today because I was using this device earlier this week. There is a company called Rig Expert, and they mostly deal in the ham market, but they have this great inexpensive, and by inexpensive, entry level I think is $300. The fully loaded one is $600. Antenna analyzer, and it basically zooms from AM to FM and higher, and it's got built-in TDR. It measures return loss. It can show you VSWR, anything you want, and it comes in. It's about this big. It has a color screen on it, and I used it to analyze and find the fault in my transmission line in La Crosse in Siberia when I was up there the other day, and I've used it actually several times for measuring. I had an AM that wasn't working, or I couldn't get it tuned correctly, so I could find out where it was resonant. I just set the range that I wanted to, looked for the dip, and went, okay, there we go. That's where it's tuned. We need to walk that in a little bit, but it's such an inexpensive piece of gear that it's really something everybody should have in their toolbox. Now, it's obviously not laboratory grade, but certainly accurate enough for what we do. And again, it's such a low price. I recommend that everybody put it in their toolbox because it's great for sweeping lines and checking antennas and, those sorts of things. And, already saved myself a ton of time by having one in the shop or in the truck.
I noticed on their website that they've got quite a few different models, and some of them are definitely for medium wave and HF. Others purport to go from like 100 kilohertz way on up to 1.4 gigahertz and so forth. Maybe do you have a model that you'd suggest right now, or do you want to email me a model number?
I think it's the 300. It's yellow. Okay. That's all I remember. I think it's the 300, and it was only, I think, $300, and that is just about AM to just over the FM band. I think it's like 500 kilohertz to 200 megahertz, which is fine for most of what I do. And
TWiRT function on its own would be huge.
Yeah, right. I mean, the TDR and everything, and it's a self-calibrating TDR. So you literally just plug it in, hit the TDR button, and it'll figure out the velocity of the line and everything else. So it took me, it just takes about 30 seconds to scan. And but even like I see, as you mentioned, just like when I had an issue with my AM where it was not really happy, I plugged it right into the transmission line, and it went, it's actually tuned about 20 kilohertz up. I need to bring that in, and then I could actually walk it in and watch the valley kind of slide back and forth. So yeah, totally worth every penny.
Cool. All right. We'll put a link to that in the show notes. Jeff Welton, you got a final tip of the week for us?
There are so many. I mean, the big one's the one that I always beat the drum. Keep them cool, keep them clean, keep them well grounded. These days, we're finding that with logistics issues, that deliveries are getting pushed out there. So in my mind, that makes it more important than ever before to push for the maintenance and just looking after the gear you got. Test your backups. It's only as good as the last time you saw it running.
Good point. Excellent. Excellent. All right. Jeff, if you have anything you'd like me to point to in the show notes, email it to me. If there's a white paper, a link, some video that you did or one of your colleagues did, you'd love for me to point out, hey, pop me a quick email and we'll put that in the show notes.
Will do.
Awesome. All right. Hey, thanks so much, everybody. It's been This Week in Radio Tech. Jeff Welton has been our guest. He's a regional sales director for Nautel. He covers the part of the country that I live in, and he seems to get around everywhere, speaks at a lot of different places. Jeff, I did not, it did not go unnoticed that you have a Wisconsin plaque up above you there. If you go to a quick widescreen, there you go. Look at there above the microphone. There's the state of Wisconsin.
I got that. I just timed out of 2 consecutive sessions on the WBA board of directors, so that they gave me that, and it was really cool. It was a fun experience. So yeah, it's and of course my wife is a Sheboygan, Wisconsin native. That's where she was born and raised.
Oh, well, there you go. How about that? Hey, thanks again for being with us, Chris Tarr. Thank you for being with us. Great to see you. And hey, your computer behaved right through the top of the hour, didn't it?
It did. It must have been the antivirus because I disabled that. So there we go.
Well, there you go. All right. Chris, I look forward to seeing you next week and look forward to seeing you next week. I want to give a big thanks to Suncast, our producer, produces each and every show. Thanks to Jeff Welton for being our guest. Thanks to Chris Tarr for being our co-host. We'll see you next week on This Week in Radio Tech. Bye-bye.